Hello and welcome to the 18th Pygame tutorial. Now, if you remember last time, what we had going is we managed to create a working map. So we have this kind of checkered tile that we can run around with. And with this map came a few issues. One, the scoreboard disappeared. So at the top left, we can't see anything. That is actually an incredibly easy fix. All we have to do is, because it's a subsurface, we just have to draw it on top of the map instead of drawing it before the map gets drawn. The second thing are these green boxes. I want to change them up a little bit on how they work. They're still going to have like a fancy phrase, however, they're going to work differently. They're not going to be, you see the whole word when it's created. They're basically just going to be a small green box that has like a number of how many letters you have to dump into it. And then, of course, you put all the letters into it until it gets all the letters it needs to form its secret sentence, and then it completes. And I'm not sure when it might show you the secret message, but probably maybe if you click on it or something. But another issue, aside from just these ones, is so firing our letters currently doesn't work. So we're giving it the cursor position on the game window, meaning that it'll register everything almost perfectly while we're in the top left corner, or while 00 is up at the top left and our maximum width and height is at the bottom right. But when we start moving, you'll notice that the firing starts to not work very well. And especially when we get past a certain point, it actually stops altogether. I can click as much as I want, but it's no longer going to fire. And that's because I'm no longer clicking inside the normal 1000 width. This is currently more than 1000 pixels to the right. But once we go back, then it will start working. And not necessarily the mouse, it's more of the player object, because once he's more than 1000 pixels out, remember, the bullets actually delete themselves the instant they get spawned, just because it's the way they work. Because we told them to clean themselves up after they've left the game window, but that won't work anymore. Now we have to tell them to clean themselves up once they left the map, and we also have to make it so this doesn't happen. So I actually got a crash. That's unique. I wasn't expecting this, but this might be a good thing. So we divided by 0 when we did our calculation for set the target. That's interesting. How did the number of frames reach 0? Should that even be possible? Alright, so it took me a minute to just try and figure this out. Apparently, whenever I have the magnitude being less than 20, then it automatically rounds down just because we're casting this to an int here in number frames. So basically, I had to recreate this problem, or I had to keep testing it to try and make sure I figured out what was happening. Whenever we click near our player, almost basically near the center, within 20 pixels of the center, it will crash because when magnitude is less than 20, it divides by self.speed, which is equal to 20, up here. And once that happens, then this gets, since int cuts off, basically, the floating point, this doesn't actually, magnitude doesn't equal at least 20, so it becomes less than 1 or 0. And then once number of frames is 0, it just crashes. So that's actually a problem. But I'm pretty sure that I can just fix this by saying something like 1 plus, in which case, no matter what happens, number of frames will always be 1 frame. So that should just fix the problem. And I don't think that'll actually offset the accuracy too much. It shouldn't, at least. Yeah, it doesn't appear to be offsetting the accuracy at all. Let me make sure I can click near the center. Yep, seems to be working. Although when I click near the center, the bullets seem to move much slower than they're supposed to. Yeah, it definitely seems to be throwing them off when I click within the box. Maybe we just have to set it so you can't actually shoot the bullets if you click within your player box. Because once I click near the center, you can see that it doesn't quite calculate that correctly. So when they move slowly like that, if I can make it do it again. Yeah, when the bullets move slower than normal, that's actually because that's when it would normally crash, but instead of just making them move slower. That's a bit strange. I'll have to look into it later because that's not going to be the focus of this episode. So let's talk about fixing the scoreboard. Now, everything else in this location draws to the map, but if you remember, if we actually say that to draw this thing to the map, you'll see what happens. It just creates sort of like a white box. Because we're drawing our scoreboard to the map, it's fixing on that one map location. So this isn't how we want the scoreboard to work. We want the scoreboard to follow us. We want it to pretty much always be in the top right corner so that no matter where our player moves, we can see it. Because say we move, all the way over to the right, it's going to completely disappear and then we don't have the scoreboard. So drawing it to the map only works if when we update the scoreboard, we update its position. However, that doesn't fix the white box problem. So what we can do instead is we can draw this thing to the game window, but not where everything else gets drawn. So we're going to consider the scoreboard like a UI element, which means that we're not going to draw it onto the map. We're drawing it onto the game window after the map updates, after we draw the map. So when we say self.map.update onto the game window, and then we give the player rec, so basically this line here, when we say this is us drawing the map onto the game window. Now let's draw our UI element onto the game window after the map has been drawn. So I could just say something like UI stuff. Because now that we're drawing the scoreboard after the map is drawn, the scoreboard's going to be drawn on top of the map according to our, game window perspective. So now when we run it, you're going to notice it's still there. But as the added bonus, because it's a subsurface, it's automatically going to just kind of, show us whatever is behind it. Because that's what we set it up to do. It shows us whatever is in the game window at that location. So even when we come over it, when we hit the top right corner, then it'll let us go under it, and it will follow us around, whether we go up or down, and of course still show us the background. Now, black text might not be the best thing to be using here, just because it's hard to see. So how about I try and switch that up? Let's see, where is our scoreboard? I believe we put it in utils. Yeah, so we fill surface with white. What is our text color? Oh, we render them all as their own individual things? Alright, let's try white, see how that looks. Just to try and, make it so it's a little easier for you guys to see. And that should hopefully be a little bit easier. You can see it a little better. It's still not great, just because the background is rather odd, but it's better than black. At least it'll be a little bit easier to see. So, now we have the scoreboard fixed. That's all right. What else do we need to fix? Well, one thing we needed to fix was the player can't leave the map boundaries. So, if you remember, our player, when he goes all the way to the left or all the way to the right, he'll actually kind of start leaving the map, which isn't good. So, there are two places we can put this. We can put it in the player itself, create maybe a new function that checks where it's looking, or checks, how far away he is, or checks if he's past the boundaries of our map. That's one way to do it. Another way to do it is just coming over to the map, because the map, if you remember, is already being given the player's rect, which means we already know if the player's rect is where it is, basically. So let's see, this function is basically just saying if player rect center is greater, so this is the scroll. So I'm just going to put some comments here, scrolls the map. Let us know what this stuff is doing. Let's say if map is past the boundaries, then, set map to max/min, just because if we go past how far the map can scroll, just set it to its max and minimum height or where it can be in its displacement. And then we can create even another set of arguments. And these ones are going to be a little bit different, because these ones are going to affect the player. Because, we have access to the player rect, so because we're being given the player rect, we can change it. Now this is pretty easy to do. Because we can directly access the player rect from this, all we're going to say is something simple like this. If player rect.left becomes less than the 0, because 0 is the left side, we don't want it going past the map boundaries, then we can just say player rect.left equals 0. It's the same idea with how our map gets offset. And elif player rect.right becomes greater than whatever our map width is, which should be something. What is our map width? 2100. So if the right side ever becomes more than 2100, then we can just say player rect.right equals 2100. And this is going to stop us from going between the left or right side. So let's run this and I'll show you at least the left side, just because I don't want to move all the way over to the right just yet. I'll center this a little bit. And now when we go over to the right side, you'll notice we can't go past it. Now, there's a little bit where if you look at the blue, it kind of goes a few pixels to the left outside the boundary, but we can't actually leave even when I hold the button down. Anyway, that's just caused because our player's movement speed allows him to move to one side. And then when I release the left arrow key, he actually goes back to being, perfectly in line. So he can move a little bit past it, but, it doesn't allow him to move infinitely past it. Now, of course, we haven't done up or down yet, but we have done left and right. So actually, you know what? I will go all the way to the right, even though this will take a little bit of time to do, just to make sure you guys understand that it's working for both sides. This bit of the text, because the rec's left and right sides, of course, we can access on their own. And then, of course, just to make sure it's working, we test the right side. So the right side's working. Now we just have to do up and down. So it's pretty much the same thing. We just say player rect dot top is less than 0. Then player rect dot top equals 0. And elif player rect dot bottom becomes greater than 2100. Player rect dot bottom equals 2100. And this will just force us, of course, to stay within the map boundaries. Of course, it might be a better idea to say, these could be 0 and be fine, but these things would have to be, map.width and map.height instead of being fixed numbers. Just like all of these ones here, these could be, map.width, map.height, whatever we actually said if we, created those two individual variables. But we didn't, so it's not really that big of a deal. I mean, we're not using more than one map ever, so it'll be okay. We just don't have access to them outside of the map. Well, now that we've got the player, so he doesn't slide off the map anymore, now we can actually get to work on the bullets, because they're going to be a little bit easier than changing the objective. So, one, the bullets kill themselves when they move too far out of the game map, or the game screen. So, we need to change up check distance, or remove it. I vote changing it. So, when they get too far to the left side, they destroy themselves. So, that's okay. That works for me. Now, when they get too far to the right side, that's where it's a problem, because it's no longer 1100 that they should destroy themselves at. We know the map is 2100, so probably about 2200 should be okay for both the top and the bottom, because those are the distances in which they're no longer inside the game map. They're no longer existing on side of our, game window, what we're playing on. So that should fix that. Now, the other problem is when we shoot them, they don't always shoot, and that's because of the way we're giving them their target. So set target gives them a target. Now, to kind of show you this a little better, I'm actually going to go to main, and we're just going to draw something onto our console. Let's see, right here should be okay. Make extra space. I'm just going to say print. We called this thing mouse, right? Let's see, mouse equals pygame. No, print cursor is what we called it. So I'm going to print the cursor. And this is going to give us the cursor's position while we play. So every tick of this game, not inside the actual game. So let's take a look at this. I'm putting my mouse, pretty close to the top left corner, and we're at 2-2. All right, let's move. You'll note the mouse is still at the same position, although it's actually moving. So now that we're all the way to the right side of the map, this should be 2100 on the right side. You'll notice the X direction, which is the first number in the console, is only 1000. That's because that the mouse position, the pygame.getMouse.getPosition, that is for the game window. Meaning that even though our player's moving and our mouse should be moving, it's staying in the same position on the game window. Meaning we don't know when we click here to shoot, it wants to shoot way over at that position, because right now we're telling it to shoot at 755, 446. That's the very top left corner. That's where we're telling it to shoot. So it's not going to shoot where our actual mouse is clicking. It's going to shoot over there where our mouse, our input is going. So to fix that, we have to change up when we give it the target, how we do this. So let's see, we give it its target back when we shoot it. So if mouse is equal to 1, so basically if we're clicking, shoot at the cursor's position. That works. However, we're going to change this a little bit. So inside, let's go back to our generic player. So the target we give it is a tuple of two values, an x position and a y position. So we're going to give it an x position and a y position, but we're going to give it as an individual tuple, and we're going to use cursor 0 for one of them and cursor 1 for the other. Now this is the same thing as just putting in cursor as its own, value. It's the exact same thing, except we're going to be able to add values now to these. Now normally tuples can't change, but when you pass them through something, you can't set the value of a tuple, I should say, but when you pass in a value, you can use the value of the tuple plus something. So in the x direction, what are we going to do? Well, we're going to do our cursor position plus our offset. Now, because our offset is a negative number, we actually will just say minus, because we'll minus a negative number and that will add it to us. So we're going to minus our map dot minus self dot map dot offset x. And the same thing for cursor y. So we're just going to take the cursor at the y position, and of course, because our offset is negative, we're just going to minus, so minus is a negative number which adds it, minus self.map.offset y. And this is going to give us the new target, the actual correct target. So now when we run this, it should be working. Let's run it. We'll center the game so you guys can see it. And let's see. So we shoot correctly now, because of course we're giving it the offset. And if I keep moving over to the right, last time, this wasn't shooting correctly. This was always trying to shoot it toward the top left of the corner. But now, it seems to be working right, because we're giving it the offset. We're telling it your new location is something, way down here at the bottom. It's going to be 2000 in the x direction and 2000 in the y direction. So that's your new target. That's the new target for these letters to go to. And it tells us our player is, at 1900, 1900. So when he shoots at 2000, 2000, that's the angle he shoots at, which of course gives us the accurate representation of it. So now we can move around, we can have accurate, aiming, and that fixes the bullets. Of course, they still despawn when they get too far out. So of course, they'll still delete themselves when they leave the game map, but they won't be deleting themselves beforehand. Alright, now for the last thing that I wanted to do in this video, and that is to change up how the objective works. So for testing purposes, I'm just going to make this a bunch of eyes, because I know that we spawn eyes and I just want to make sure that this is going to work the way that I imagine it. And we're also going to change up the size to be significantly smaller, because these are just going to be like little boxes. They're not going to be big boxes anymore, because they're not going to display the text inside of them. They're just going to display like how many letters you need to put in them. This also means we don't need the ghost text. However, we do need to add something else. So this has to do more with the way I want to draw it than anything. What we could do is we could just draw the next letter it's looking for as like a big image on top of the box, or we can draw what I want to do is I want to draw, say we have 13 of 144 characters that we need inside of our box. But to do 13 of 144, you can't just make a string like this. So you can't just, get the number as a string plus do something like a \n, which would create a new line of \n, and then of course, the other number, which would be, maybe 100. You can't do something like this because the font.render doesn't actually handle the \n. It will treat the \n as an unknown character and just create a box. So this method doesn't work. What we have to do instead is create a list of things we want to draw. So I'm just going to create, I can't call it list, they're like elements, I guess, is what I can call them. And this is just a list, which is, basically an array for any other programming language, but Python likes to call it a list. And inside this list, we're going to give it three strings in an order that we want to draw, or however many strings we want to draw in the order. So the strings are going to be, the first one is the display message size. So we're going to say the string of the length of the self.displayMessage. And make sure I get enough of those tabbed out. Self.displayMessage, closes length, closes the string. Alright, this is a little confusing why I'm getting so many errors. We'll just continue. Oh, we have 2 extra of these. So the next thing we're going to draw is just of, because we want to say like how many characters we have of the max number of characters. So that's its own element. And the last one is another string of the length of self dot win message. And why is self giving me such a problem here? Oh, we have this weird square bracket there. That's why everything's acting weird. All right. So now our text and our image are also going to be a bit different. So we have this set of elements that we want to draw, each on their own line. So to say this, we're going to say I'm going to call them strings because that's typically what a series of characters are called. You can call it character array or anything, but string just seems to make sense to me. So for each string or for, each sentence or for each char array, this is whatever we want to call it. So this is the thing that we name whatever we want. So for every string in elements, what do? Well, we want to, do a utils.getFont. Let's leave it at 20 size .render whatever the element is. So we're going to say the string, which for string and elements is going to go, okay, so for the first thing, which is a string, which is the display size, then the next thing, then the third thing, it's going to go in that sequence. So for every string, we want to render the string, with true and utils.black. So we just want to render what the string is. And then of course we want to blit this thing because this is just happening of its own. And what I should be saying is self.text equals this thing. And then we're going to say self.image.blit self.text. We're going to blit what the text looks like at this point in time, which at first is going to be, 0 of, 19 or something, however many characters we have. And we're going to blit this thing at, well, it's 80. It's probably not going to be too much. So let's go 20 in the x direction, and the y direction is where it becomes variable. So I'm going to say something like give it a 5 offset plus we need some type of iterator times, a little bit more than the font size. That way each, letter has a little bit of spacing. So what is the iterator? Well, we would need to create something that every time we go through this loop, we have the iterator go up. So what we could say is we could say I equals 0. And then, every time we go through this loop, just I plus plus, or I can't actually say that, I plus equals 1. Python doesn't let you say plus plus. So I could say this, and this would work. This would allow I, be 0. At first we blit it to just 5 plus 0. Then the next time we blit it to 27, and then we blit it to 49. Yeah, 49. So that's how that would go up. Or I can do something a little nicer, a little cleaner than having to, create this. We can create an iterator on its own by enumerating the elements. So what we can say is for iterator, string in enumerate elements, which this is just a way of compacting everything together. Now we've created an iterator called I, and we still have access to the individual elements called string, because we're just enumerating elements. So now what this is going to do is this is going to draw us 3 lines. It's going to go through this loop the first time. It's going to grab the length of the display message, which should be 0 to start with because there's nothing there. It'll render 0. It'll go to a new line because, we're basically timesing the y position differently. So it'll go to the next element. It'll draw of text on a new line basically. And then it'll go to the third element and draw the win message length on a new line. So it will tell us, 0 out of 15, meaning that this box contains 0 out of the 15 characters it needs to be completed. And then, of course, because we're drawing all those, we just say self.rect equals whatever, and we set the position of the objective itself. So this should work, at least in its basic sense. Let's see, 0 out of 11. So we have 0 of 11. Our nice little objective box here is working. Let's hit spacebar once this red guy goes away. so that we can, well, more red guys are spawning. But now you can see 1 of 11, 3 of 11, and the reason it's saying 3 and 5, it's going by 2s, is because spaces are counted as characters. We probably don't want that to be the case ultimately. However, there is an issue that we get to when we hit the last one. It crashed. How did I know it was going to do that? Well, that's because we're checking. Before, we never actually filled out our sentence entirely. Back here. So let's see. Yeah, here we never actually filled out our sentence entirely. So when we actually check this thing as it is, what happens is we're looking at the element past the one we just filled. So when we fill the last element, what we're trying to do is in the self.objective-win message, we're trying to access the element past it. You know, we try to access the next element, but the objective is already completed, which means that this is going to give us the error because it's trying to access something that's further than it can access. Because if our string is 13 characters long, we're trying to access the 14th position, and that's impossible. So this has the one issue that we have to actually kind of check if the objective is equal to itself. The win message and the display message are equal before we check this. Just because if we don't check that, then you know, problems will happen. So I'm just going to say if self.objective.win message is the same thing as self.objective.display message. And I missed a V here. And then I will tab over this stuff. Because what this is going to say is if they're equal to each other, then don't try and check the next position because it doesn't exist. So this should solve that problem. If all goes well and everything hopefully works the way we want it to, then it will solve that problem. It's no longer colliding. It's strange. Oh, it's not looking for it because... Oh, if they're not equal to each other, that's the problem. If they're not equal to each other, then you can check this. If they're equal to each other, stop trying to check the next position. I just did that backwards. So now everything should work the way we want it to. Let's try this. We hit I. We can throw more eyes at it, even more so. And let's see what happens when we throw the last one at it. It fills up and it works. And now when we hit space, it's not, it doesn't demand any more letters, so it's done. Now at this point, when it's equal to itself, or, we have 11 out of 11, this is where, stuff might be able to happen. Basically, we might be able to open it up, get some reward, or, I don't know how it works. Maybe we get more score or something. But that's when it's completed. That's when we've finished the objective. Now, we actually got an interesting error because it filled up, but it still accepted the letter we shot at it. That could be a problem if you accidentally shoot a letter at it when it's full. What exactly error is it? Template equals... Yeah, it's just equaling the wrong thing because we're updating template every frame, aren't we? Yeah. So it's just giving us a wrong thing because we check the collision when they happen. So basically a collision happened and we immediately set the temp letter equal to whatever we were looking at. So yeah, that could be a problem. We probably could just, again, put another check in. So if the objective is not equal to the win message is not equal to the display message, then you can do the collisions in the first place. Because otherwise, that just becomes an issue. So it might actually make the sense to fix that now. So basically we can take this thing that we just made away. We can just get rid of it. Because we're going to put it a little bit higher up in the if logic. Move this back. And when we do our collisions, so we're doing a collision between the objective and the player bullets. So self.objective is only ever a single objective. We might have to change up how this works if we want more than one objective to exist in the game at one time. But basically, we get the collisions for the bullet in the collision. We can check all the collisions. We just don't want to care about anything if they're equal to each other. So right here, I'm just going to add the if statement. Basically, if they're equal to each other, then don't do anything at all. just ignore this entire statement if they're equal to each other. Because if they're equal to each other, just, skip everything. Don't try and add more things to it. We're done with it. So this should fix the problem, hopefully. I believe it will. Of course, this is why we test things. I just want to make sure that this is working entirely before next time so that I can actually get to work on finishing up how the objectives are going to be handled. See, there we go. We have 9 out of 11. Hit the last one, and it gave us an error again. Oh, because we need the check in both places. That's interesting. What happened for that error was, so, if they're equal to each other, we won't do any more checking. However, they become equal to each other during this set, during when we add the bullet to it. So right here, objective display message plus equals the temp letter. Now they're equal to each other. So now, let's do this annoying statement down here. So I will just do another check, I guess. And that should solve everything. Again, hopefully, this is why we have to test things. 1 out of 11, 3 out of 11, and it's also possible that we can, instead of having these be the character values, we can kind of go through the strings firsthand and get the actual characters, ignoring the spaces. That's a possibility. 11 of 11, we'll shoot it, and nothing happens. Holding space doesn't do anything, shooting it doesn't do anything. So now it's completely resolved. There we go. We have the objective working the way we want it to. At least for what this video is going to show, because we're kind of running out of time / out of time. Well, that is going to be it for this video. What we did is we fixed up some of the stuff with our game. We made it so, our player can't go outside the map. We can actually shoot our bullets properly anywhere around the map by changing up, giving basically our mouse an offset when we shoot them, so that, our bullets can go anywhere. We changed our objective, how it works. We fixed the scoreboard. Next time we'll probably work on the objective more, getting it so that they kind of randomly spawn around, getting it so that when we hold down space we only target a specific one, particularly the one closest to us, and maybe getting them so that they randomly generate. So around the map there are certain, the objective generates and you have to go finish the objective, and then once you finish it you get some boost to your score or something. And maybe have them drop, some extra letters when you finish the box, or give you maybe some type of power-up. Who knows what happens when you finish them? That's stuff we can decide later. But that's going to be it for this video. Thank you for watching. Hope to see you next time.